Okay, now we have solving rational equations. So we talked a lot about the least common denominator when we were adding and subtracting, and then we just did the complex ones. So we're still going to be looking at the least common denominator, but now since we finally have an equal sign, we can use that LCD to actually get rid of our fractions. And then we're going to wind up with something that's either quadratic, so we're going to factor it and solve it, or we could end up with something that's linear. So our first one, we have x over 2 plus x over 6 is equal to 2 over 3. And 2, 6, and 3 are our denominators, so we're going to pick our LCD of 6. And you can see that each term on both sides of the equation is getting multiplied by 6 over 1. And then we're going to simplify. So 2 goes into 6 3 times. We end up with 3x. And then 6 goes into 6 once. So we just have 1x. And then on the other side, 3 goes into 6 twice. And we're left with 2 times 2, which is 4. So now we went from these rationals, and now I got rid of all those denominators. So just 3x plus x is 4. Add like terms, we get 4x equals 4. Divide it out, and our solution is x equals 1. So that's what we're going to do. We're going to still look at LCDs, but we're going to use them to get rid of our fractions. So I have a denominator here of n and a denominator of 3. So my LCD is 3n. So I'm just going to rewrite this. The 4 over n has to be multiplied by 3n over 1. And then that n plus 1 over 3. I'm multiplying that by 3n over 1. And then the 1 on the other side also has to be multiplied by 3n. So these n's are going to cancel each other out. And I get 4 times 3 is 12. Here the 3's cancel. And then I have n plus 1 times n. And on the other side, 1 times 3n gives me 3n. I'm going to distribute this out. And then also you have to be careful because there's a minus sign in front. So we have to change the signs of everything. So I get 12 minus n squared minus n is equal to 3n. So this time I have a quadratic. I need to set it equal to 0 and factor it. And because this is negative and I need my coefficient of the square term to be positive, I'm going to add everything, or I'm going to move everything to the right side. So I'm going to subtract 12. I'm going to add n squared and add n. So all this is just gone to a 0. And then let's just write it in the right order. So n squared goes first. 3n plus n gives me 4n. And then I have that minus 12. So we can factor this. Negative 12, the factors we're going to use the 6 and 2. So n plus 6 and minus 2 will give us the correct middle term of 4. And then we set each factor equal to 0. So one of my solutions is negative 6. And the other solution is positive 2. And I'm just taking a quick look at my original problem. I want to make sure that it wouldn't give me a division by 0. So remember we talked about that in the first section in chapter 7. And neither one of them, when I plug them in, would give me a 0 on the bottom. So both of these solutions are okay. So n could be either a negative 6 or a positive 2. Okay, number 2. I have one denominator is y plus 2, one is y minus 1, and then y squared plus y minus 2 factors to y plus 2 times y minus 1. So this encompasses these other denominators. That's going to be my LCD. So my LCD is y plus 2 times y minus 1. So we have to multiply every single term by the y plus 2 times y minus 1. So every single term, I multiply the y plus 2 times y minus 1. So the first one, the y plus 2's cancel, so I'm just left with 4 times y minus 1. And I'm just going to go ahead and distribute that out. So 4y minus 4. Then the y minus 1's cancel. I have 2 times y plus 2, so that gives me 2y plus 4. And on the other side, the y plus 2 and y minus 1 cancels, so I'm just left with 12. Here I don't have a square term, I have linear, so I can just combine like terms and solve for y. So 4y and 2y gives me 6y. Negative 4 and a positive 4 cancel. So I have 6y equals 12, divide by 6, and I end up with y equals 2. And again, just to check, that's okay, right? When I plug in 2 here, I get a 4 on the bottom, I get a 1 on the bottom there. This would give me 4 times 1, because that's just a combination of those two. So none of these terms are going to give me a problem, so y equals 2 is a solution. Okay, here we have 9 over x plus 3 plus 3x over x plus 3. So these already have a common denominator. So to make my life a little bit easier, I'm going to add these terms together before I clear them out. So x equals 9 plus 3x over x plus 3. So the only denominator I have to worry about is the x plus 3. So that is my LCD. So I'm going to multiply this side by x plus 3 over 1, and I'm going to multiply this side by x plus 3. So these cancel, and then I'm distributing here, so I get x squared plus 3x equals 9 plus 3x. I have a squared, so that means I have to set it equal to 0. So I'm going to subtract 9 and subtract 3x. From both sides. So that gives me a 0. The 3x and the minus 3x cancel, and I have x squared minus 9. So here is the difference of two perfect squares. So it factors to x minus 3 times x plus 3, and set each one equal to 0. So when we set x minus 3 equal to 0, we get x is 3. And when we set x plus 3 equal to 0, we get x is equal to a negative 3. Now this time there is a problem, right? If I plug in 3, that's okay, because I'd get 6 on the bottom. But if I plug in negative 3, I'd get 0 on the bottom. So I have to throw this solution away. The only solution I have for this one is x is equal to 3. So that's why we have to go back and check. All right, number 4. If you factor this, it's x times x plus 4, which is just a combination of these two. So my LCD is x times x plus 4. So I'm just going to write them out for each term. And because this is a subtraction, I'm just going to make that a negative 1 up top so that I don't mess up my signs later. Okay, so first one, the x's cancel, and I'm left with 3 times x plus 4, which is 3x plus 12. Here the x plus 4's cancel, so I just have negative 1 times x, which is negative x. And then on the other side, everything cancels, so I'm left with a 5. No square terms, so I'm just isolating my x. So 3x minus x gives me 2x plus 12. Is equal to 5. I'm going to subtract 12 and then divide by 2. So I get x is equal to a negative 7/2, which is fine because the only thing that I'd have to worry about is x equaling 0 or negative 4.